Question 10 is just an activity, starts off with just an activity scheduling network, whatever you want to call it. You don't need to really read this. I mean, you can if you want. We just need to do the early and late time. So, as always, we start with 0 and 0. And then we have to have a look. So, if we're going to go here, the earliest you can complete it is 3. So, we're filling in all the early times first. Earliest you can get here is obviously 5, and earliest you can get here is obviously 2. Now it gets tricky. So, the earliest we can get here, this would take 4 days. But that's not the earliest we can get here, because this also has to be done. So the earliest that we can get here, in fact, is 5 days. You have to take all the activities going into it into account. That means we can do this one next. So here we have 5, here we have 12, and here we have 2. So obviously 12 is the earliest we can get there, because we have to have all of these done, and that means we have to have the 12 done as well. For here then, we have 6, or we have 12. Obviously, the earliest we can be there then is 12. Going to here, the earliest we can be here, there's only one option, it's 15. As for here, the earliest we can be here is 17. This one's 18. So 18 is obviously the earliest we can get there, because this one has to be done. They all have to be done. This one's done in 17 days, but this one's done in 18 days, so this can't all be done. The earliest they can all be done is 18. Then here we have 8, here we have 16, and here we have 19. So the earliest we could be here is 19. Then finally, the earliest we can be here is 19 or 21. 21 is therefore the earliest time we can be at the very end. It's also the latest time we want to be there, because we don't want to delay the project. And now we work backwards. So 2, that'll give us 19. So now we're working backwards. So 21 minus 2 gives us 19. So we have to be here by day 19 or it'll be delayed. 21 minus 4 will give us 17. Yep. So if we start, we can get, the earliest we can get here is 15. But if we wait until day 17, it won't delay it, because 17 plus 4 will still make it on time. And that's kind of the idea that we're doing. So now, let's have a look at this one. There's only one option. It can only be 18, because there's only one arrow going in and one thing that it needs to do. Going into here, there's 2 options. So either it's going to be 12 or it's going to be 14. So obviously we need to start it as soon as possible, so we choose 12. Because if we chose 14, then we'd have 14 plus the 6 would give us 20, then we'd be late here. So that's why we're choosing the smallest ones now instead of the biggest ones. Going into here, we have either 15, or we have 13, or we have 12. Obviously it has to be 12, because again, if it was 13, then this would be delayed, because it says the latest we can be here is 12. If this was 13, then we'd get here on day 13, and the whole thing would be delayed. Going into here, we have either 16 or 12. We choose the smallest one, which is 12, again, because we need to be there. Going into here, there's only one option, so if we get here by day 11, that's fine. Yeah, because 11 plus 1, 12, then it's all good. How about going into here? We have either 5, or we have 12 minus 7 is 5 either way. And then finally here, we have either 12 or we have 8. We're going to choose 12, of course, because we want to be here. Or actually, sorry, 12 is too late. We're choosing the smallest one, remember, so we choose 8. Because if we chose 12, this would be delayed, so it has to be 8, so this isn't delayed. Then we have to write down the critical path. So there's only one critical path, because here, this can't be delayed at all. This can't be delayed at all. This one can be delayed, so I made a mistake when I was doing this by myself for the first time. This can be delayed, so this isn't a critical path. And as well as that H here, this can also be delayed, because 12 plus 4 is 16. There's no time rush here. This isn't a critical path, so neither of those are. But this is, because we get down here to 12. And then we have 6, that can't be delayed at all. 18 to 19, 1 day, no delay, and that. So yeah, there's only one critical path, and that's it. So we start at B. Then we go to E. And then we don't go to either of those. We go to J next, down here and up to J. And then L, and then M. And that's the only critical path in this network. So then for the last 2 parts, they're kind of theory, so I just typed out answers. So what is a critical path? A critical path, just say something like this will work. It's the path along which all the floats of all the activities are 0. So float basically just means how much leeway do you have, or how much can you delay the activity. So for B, E, J, L, M, B has to start on 0 and end on 5, and it takes 5 days. Has to start on 5 and end on 12 because it takes 7. J has to start on 12 and end on 18 because it takes 6 days. Same here, same here. The reason, an example of one that wouldn't have a float of 0 is, for example, D here. D can start on day 3 and it takes 1 day to complete, and that would bring us to day 4. So you can see that D, we don't have to start on day 3. We can start D on day 11, and we'd still be done by day 12. So we basically have 10 days. No, not 10 days. We have 8 days of leeway, because if we get here on day 3, we can delay it by 8 days till day 11. Then 1 day we'll still arrive there on day 12. All good. So it's about how much leeway we have. So another way you could say is the path along which no activities can be delayed without delaying the whole project. Because obviously you technically could delay all the activities, but then the whole thing would be delayed. The part 4 then said if activity K takes 5 weeks instead of 3 weeks, what effect will this have on the critical paths and the time taken to complete the project? So that would mean this would be 5. So I'm going to color it in red. So this would become 5. Scroll that out. Which means 12 plus 5. The earliest we could be done here then is 17. And of course that's also the latest we could be done by, because 17 plus 4 brings us 21. If this was 18 plus 4, that'd be 22. We'd be delaying the project. So it would have no effect on the existing critical path, because you can see that still these haven't been affected. The BEJLM, they still cannot be delayed whatsoever. But there's a new critical path, BEKN, for example. So the reason BEKN is because now we can't delay this, because it starts on day 12, ends on day 17, and takes 5 days to do. And then this also can't be delayed, because from 17 to 21 takes 4 days, can't be delayed. So we have a new critical path, but the project won't be delayed since activity K can start in week 12 and finish in week 17, which is the late time. So it can start on day 12, and if we start it straight away, we'll be on day 17, plus the 4, 21, nothing's delayed, and it's all good. So the project won't be delayed, but there's a new critical path. So that's what would happen if it was equal to 5. But I'm going to move it back to what it was now. I believe this was 15. Yep. For part B then, they decided to throw in a differential equation for whatever reason. So we have this uniform cross-sectional area, so the rate will be constant. We don't have to worry about the radius changing. Height x leaves through the pipe at its base, rate at which it decreases proportional to x, and we're given some initial information. So basically the rate at which the height decreases, so the height is x, so the rate at which the height decreases, or dx dt, is proportional to x. So I'm going to write minus kx. So you could write positive kx, it actually won't make a difference in your final answer. The only thing is, you will get the opposite. When I solve for k, you'll just get the opposite sign to me. So we can just solve this now. We'll get dx over x equals minus k dt. So then we do the integral of 1 over x dx equals minus k is a constant, we can take it out, times the integral of dt. Normally I like to do the limits, but this is kind of weird in the limits, and we're not going to get an answer of x and t if we use the limits, so I'm not going to use limits here. So we'll get the natural log of the absolute value of x equals minus kt plus a constant c. Okay, so now what can we do? Or actually we can use some initial information, which I'll do because why not. When the time is 0, x is equal to h. So when time is 0, x is equal to h, it goes up to some number x, and this goes up to some number t. So what we'll have is ln x between h and x equals minus kt between t and 0. So it's going to be ln x minus ln h equals minus kt minus, sorry, it's going to be plus then k times 0, because we have a minus here, and then we have another minus because we do the top one minus the bottom one. That'll make a plus. Not that it matters though, because it's just 0. ln of x over h will be equal to minus kt, e to the power on both sides, and the ln's will cancel, and we get that x over h equals e to the power minus kt, or in other words, x equals h e to the minus kt. Now we need to find t when x is h over 8. Problem is we still don't know what k is. That's why they gave us this information. When t is 45, x is h over 3. So we have h over 3 for x equals h e to the minus k times 45 is what t is. So we can see the h's will cancel. Oops, that doesn't look like a 3. The h's will cancel. We'll get 1 over 3 equals e to the minus 45k, we can say. ln on both sides, we get ln of a third equals minus 45k. That means that k equals 1 minus 1 over 45 ln of a third. Put that into your calculator. Well, actually, I won't put it into my calculator because I'd rather get a definite number, because this ln could cancel out with the e, so I'm actually going to leave it like that. And if you decided up here that k would be positive, you would get positive this number. And then you see when I sub this in, the minus will cancel with this minus and I'll get positive. If you were to do positive k, you just get a positive number, so it would all work out in the end. So x equals he to the minus kt. X equals he. And then instead of minus k, I'm going to write 1 over 45 ln 3. Well, all right, t ln a third over 45, I guess. T over 45 ln a third. You could probably just get a decimal, it'd be fine. And then you can swap these around technically, and then the ln will cancel. If you want to make it really simplified, you can do that. You can do he, and then for multiplying powers, you can do it like this, to the power of t over 45, and then they'll cancel, so you'll get the x equals h, and then e and ln cancel, and you'll get 1 over 3 to the t over 45. Or in other words, x equals h times, or h over 3 to the t over 45, because 1 to the power of that is just 1. So you can simplify it like that, or you can leave it like this. When you plug in, it shouldn't matter. What's t when x is h over 8? Well, let's have a look. So x is h over 8 equals h over 3 e to the t over 45. Or not 3, why did I write e? 3 to the t over 45. Which means that the h's will cancel. Look at that, 8 equals 3 to the t over 45. Log base 3 on both sides. We got log base 3 of 8 equals t over 45, such that t will be 45 times log base 3 of 8, which is equal to, and we get that t is about 85.18 seconds, and that's our answer. I'll quickly go through it. If we decided not to do all that messy simplification, you can leave it like this, that's no problem. I'll copy it down here. X, we want to see what t is when x is h over 8, so we get h over 8 equals he to the t over 45 ln a third. You'd get an eighth equals e to the, because the h's will cancel. Do ln on both sides, you get ln of an eighth equals t over 45 ln of a third, which means that t equals 45 ln of 1 over 8 all over ln of 1 over 3. And if you put that into your calculator, you also get 85.18 seconds as your final answer.